Hi class, I hope you're doing well. Here's just a quick lesson for today. Now that you're done your Unit 2 test, we're just going to do another lesson that is going to expand on that Unit 2, which I told you that we'll just kind of move it till later, so now it's later. So we have 2.5, solving equations with a distributive property. So we're going to do these examples, which you should know how to do, which is solving the equations when you have variables on one side and on the other side. So remember, when we solve equations, the end goal is always to have x equals. So we're trying to find out what the x value is equal, and it has to be by itself with only one of it. So to get there, we have to bring all the x's together. So we notice there's this 2x on this right side, so we're going to bring it to the other side. And when you bring it to the other side, you're going to change it into a negative 2x, okay? And then we have it equal to 21. So I rewrote everything else. The 5x is still over here. The 21 is still over here. But I moved 2x to the other side, and it changes the sign. So it becomes minus 2x. Or if you can want to think about it, I took 2x from this side, so I have to take 2x away from this side. What's left over is 3x equals 21. Because I'm collecting 5x's, I subtract 2x's, so I only have 3x's left over. But that's not where I want to be for my final answer. I need x to be by itself with a 1 in front. So that means I need to get rid of the 3. And to get rid of the 3 is currently being multiplied by x. So I'm going to divide it by 3 to get rid of that 3. But if I do this to this side, I also have to do it to the other side. So then I have to apply 21 divided by 3, which gives me 7. So my x value for this equation is x is equal to 7. Let's just do this one more time to just refresh our memory. So here's another example. I have 2x equals 18 minus x. Now I want to collect my x's to one side because my end goal again is still have x equals. So if I move the x, this negative x, remember the sign that's in front of the term has to go with it. So it goes to the other side. Or if you can think about right now on this side, it's minus x. So I'm going to have to add x to the side, and I'm going to have to add x to this side. I rewrite everything else. I have a 2x on this side. I have the 18 on this side now left over. So now I have 2x plus x. So that gives me 3x's, right? I have 2x. I add another x. I have 3x's. I have it equal to 18. Again, I have this 3 that's stuck in front of the x. So I'm going to divide out the 3. And what I do to one side, I do to the other. So now my x value is equal to 6. Great. That was before the test. What we're doing today, which I kind of gave you a glimpse to that one class day, is we're now going to solve equations where there's brackets in the equation as well. So let's go and talk about this word that we need to know that will help us deal with the brackets. And that is called the distributive property. When you think of the word distribute, the key word in this word is distribute. So that means that we're going to have to distribute something. Another word for that could be like sharing things, or another word for that could be applying things. Okay? Before we get into the equation, let's just look at an expression with a bracket, like this one here. We have 2 bracket 3x plus 4. Now, 2 in a bracket with numbers and variables, what we're always doing is adding, subtracting, multiplying, dividing. So then you might be saying, well, what's this operation here? So when there's no operation and you see a bracket, that means it's an invisible operation of multiplying. Okay, so it really means that it's 2 times this bracket. Okay, so it's 2 times the bracket. And what's inside the bracket is 3x and a plus 4. So if 2 is being multiplied by the bracket, it means I have to, what we call, distribute the 2 to everything inside the bracket, because there's 2 of everything in the bracket. So that means if there's 2 of everything, that means it's really 2 times 3x, which will give me 2 times 3 is 6, and then x just follows along. But that 2 is applied to the bracket. So it doesn't mean it only applies to the 3x. It means it applied it also to the 4. So that means 2 times 4 as well, which would be a positive 8. Remember, you always do the sign with it. So if it's a plus 4, it's a positive 4. So 2 times a positive 4 gives me a positive 8. So that's what happens. So we have a 2 with a bracket, 3x plus 4. That means I have to distribute the 2 to everything inside the bracket by using the operation of multiply. So I do 2 times the first term, which gives me 6x, 2 times the second term, which gives me plus 8. Are you ready? Let's do a couple more examples just to make sure. So here's another one. Now this one, it says 4x plus 3 bracket x plus 2. Remember, this bracket with the 3 means that 3 gets multiplied with everything inside the bracket. Now you're wondering, well, which thing do I do first? Well, when we're just doing the expression, we always do and follow BEDMAS. BEDMAS or PEDMAS. But the idea is that we deal with, what does the B stand for? Brackets first. So we cannot do this addition between the 4x and the 3, because that's not what BEDMAS tells me to do. I have to do my brackets first. So to do my bracket, well, you're thinking, well, does that mean you have to add x plus 2? No. We're dealing with brackets when there's a number in front, well, you can't add 2 and x. So then that means that you have to do what's in front of the brackets as well. And that means we're going to do that distributive property where we're going to distribute 3 with each part of what's inside the bracket. So 3 times x would be 3x, because there's an invisible number of 1 in front here. Then 3 times a positive 2, this is also a positive 3. So 3 times 1x is really a positive 3x. Positive 3x times a positive 2 gives me a positive 6. And then what's left over is you still have this 4x in front. All right, so remember, this purple is me distributing that positive 3 to everything inside the bracket. 4x is now just sitting in front. And now I have an expression where I have to collect my like terms, which is 4x, and then I add another 3x. So now I have left over is 7x's, and I still have just my singular 6 at the end. Okay? Let's try one more just to make sure. Now I have this expression. So now, as you learned, just like before, I'm going to have to deal with this bracket first. And that means I have to distribute. And what I'm distributing is this negative 2, right? The sign in front of it goes with it. So I'm going to be distributing it to each of those things inside the brackets. So negative 2 times a positive 1y, which gives me a negative 2y, because negative 2 times 1. Negative 2 times a positive 4 will give me a negative 8. Okay, negative 2, positive 4, multiplied gives me negative 8. Then I'm just writing what's left over, which is the 5x that was in front. So I have 5x minus 2y minus 8. Now, do we have any like terms? No. This one is x's. This is y's. You cannot collect them if they're not the same. Right? Okay. Hopefully you understand how to deal with those brackets. All right. Well, that's one thing. The other thing is, now when we're solving an equation, remember, like before, did we really follow BEDMAS? We didn't. We dealt with the addition and we got rid of it first, and then we got rid of the multiplication. So remember, when we're solving an equation, we don't really follow BEDMAS. We follow SAMDEB, right? S-A-M-D-E-B, SAMDEB. So we get rid of all the additions and subtractions, then multiplication, division, and then the exponents, and then the brackets. So the bracket, when we do equations, is the last thing we do. Well, so if I write BEDMAS, or if you're okay with that, instead of writing BEDMAS, I'm now going to write SAMDEB. It's just the opposite of BEDMAS. Okay, so that means I gotta deal with addition, subtractions first, then multiplication, division, then exponents, and then brackets. So if you look at this equation, the only subtraction or addition I see is inside the bracket, and you can't subtract 1 from the 2x, so because they're not like terms, so they're going to stay in the bracket. The next thing is multiplication and division. Hey, isn't this 3 in front of the bracket? Do you remember what I said? I said that it is a multiplication with a bracket. So according to SAMDEB, if I'm solving the equation, I have to get rid of that 3 because it's being multiplied with what I need, which is the x. So to get rid of a multiplication, what do we always do? The opposite, which is to divide by 3. So that gets rid of the 3. But what you do to one side, you have to do to the other side. So I got rid of the 3 on this side by dividing out the 3. So I'm left with just a 2x minus 1. On the right side, I have a 21 divided by 3, which is 7. Now, some of you might ask, hey, what happened to those brackets that were around here? Well, when the 3 got eliminated by dividing out, it left it with just a bracket 2x minus 1. While the bracket was just a placeholder because it wanted to be multiplied by the 3. Now that the 3 is gone, I can now open my bracket and it disappears. Okay? So if that's the case now, sorry, I'm just trying to move this down. Nope, it's not letting me. Nope, okay. Anyways, so if that's the case now I can follow the rest of SAMDEB. So I got rid of the multiplication division, and yes, I would do exponents and brackets, but because there's nothing there, I would now go back to the beginning and do any addition, subtraction. And so remember, our end goal when we're solving equations is to have x by itself. So I need to get rid of that minus 1, just like before, move it over, or if you can imagine doing the balance method, I would add 1 to this side, means I add 1 to the other side. So I have 2x is equal to 7, and I just added 1 on this side. Ooh, I'm going to need more space here. So I would have 2x is equal to 8. And now to get rid of that 2 in front, I divide both sides by 2. I'm just going to run out of space, so I'm going to make an arrow. That got rid of the 2. So my answer is x on the left side and 8 divided by 2, which is 4. Are you okay with that? All right, let's do one more example just to make sure. Again, we have a negative 2 bracket 4x plus 6 equals 28. So, as I mentioned, remember, another analogy I like to think about this is that the x is your gift for Christmas or whatever, and you're trying to get at it, or your birthday, for example. So to get at it, you have to unwrap all the wrapping paper that's around it. And you always start on the outside wrapping paper, not the box in which your game or toys is on the inside. You have to get rid of the wrapping paper first. So you gotta get rid of the negative 2 to open up the bracket. Then you gotta get rid of this plus 6, and then you can get rid of the 4. Hope that analogy helps you. Anyways, so as you mentioned, we're trying to get rid of this negative 2. So I gotta divide out the negative 2, because the operation between that negative 2 and the bracket was the multiplication. So divide out the negative 2 on one side, I have to do to the other. So that's gone. I'm left with the 4x plus 6. Remember, I just got rid of the negative 2. I unwrapped my gift. I have 4x plus 6 left over. On the right side, 28 divided by negative 2, which would give me a negative 14. Now, I need to get rid of this plus 6. I don't know, you can call it like the tag or something on your present. Move that to the other side. So that becomes a positive 6 becomes a negative 6, or imagine taking it away. I have 4x is equal to negative 14 minus 6. So I have 4x is equal to negative 20. Then I can unwrap the box of my Minecraft game or something you want. So I divide that side by 4, divide this side by 4. So my answer is x is equal to negative 5. Okay,